Renowned for their dramatic snow-capped peaks and thick pine forests, the Rocky Mountains supply water to more than 60 million people in the West. But this crucial watershed is in peril due to a tiny insect called the mountain pine beetle, a species of bark beetle.
Roughly 90% of the lodgepole pine in the state of Colorado has been killed by the bark beetle. So we're talking about 4.5 million acres of trees.
This loss of trees has changed more than just the landscape of the West.
We've changed the balance of the watershed because we've killed some of the trees.
With funding from the National Science Foundation, hydrologist Reed Maxwell from Colorado School of Mines and John Stednick from Colorado State University are leading a team of scientists to study the impact of bark beetle tree kill on water quantity and quality.
One of the things that we're trying to look at is how this is affecting water quantity and water quality in the Rocky Mountains. So right now in the state of Colorado, about 2.5 million people are affected. Their drinking water can potentially be affected by the pine beetle epidemic.
The bark beetles are native to North America and are not harmful under normal circumstances. But warmer temperatures and drought over the past 10 years have led to a population explosion of beetles. And that has changed three major processes of the water cycle in Colorado: snowpack, runoff, and what's called evapotranspiration.
Evapotranspiration is a combination of evaporation and transpiration.
That is interrupted with beetle-killed trees. And this is complicated because the beetle-killed trees don't transpire anymore, and so that will change the water cycle.
Healthy pine trees, through transpiration, draw groundwater into their roots and leaves and release it into the atmosphere during photosynthesis, almost like sweat. Beetle-killed trees cannot transpire, which leaves more water in the ground to eventually run off. And dead trees have no pine needles to intercept snow and help shade the snowpack from the strong Colorado sun.
We get a deeper snowpack because there's less tree, less foliage to intercept it. And we have that snowpack melting off more quickly because there's less shading.
Without shade, more water from snow or rain evaporates or becomes vapor, forming clouds in the sky and leaving less water to melt and run off to streams. The combination of less evapotranspiration and earlier snowmelt means a shorter snow season in Colorado, increasing the amount of water yield in the early spring and leaving the soil drier in later months. Yet the dead trees are not only affecting the quantity of water, but the quality as well.
The dead trees, the dead forests, they basically will release and have needle fall over a period of time. Those needles on the forest floor will start to decompose.
Decomposing pine needles mix with runoff to form a smelly, bad-tasting pine tree tea. By doing field collection and lab analysis on stream and runoff water, Stednick and Maxwell discovered that these fallen needles are causing a change in the natural chemical makeup of Colorado's drinking water.
We're looking for metals and how they can be mobilized. We're looking for organic compounds, as well as potentially nitrogen.
While not necessarily harmful, organic compounds have to be balanced delicately when pre-treating water for consumption. Changes in organic carbon levels could lead to unsafe drinking water. In fact, Maxwell and Stednick's team has measured higher levels of organic compounds in the soil beneath trees killed by bark beetles than in the ground under healthy trees.
There's always needles that drop onto the ground and decompose, but we see a much greater amount of litter and tree fall and stem fall and then eventually trees that fall over. So we see a big change in the carbon balance.
While the water in Colorado is still safe to drink, more research is still needed to determine the extent of the damage these organic compounds are causing.
What is the long-term effect? What is the legacy of these bark beetles? How long is this decomposition and production of organic carbon in the rivers going to last?
Earlier runoff and snowmelt periods, combined with less evapotranspiration and pine tree tea, are likely to be part of the challenge of sustainable water in Colorado for several years, all because of a tiny bug.